Okay, good morning, everyone. Um, we've been doing a lot of kind of work on our own, haven't had a lot of contact back and forth. Mostly investigation stuff where you just kind of drew a graph based on what you saw on the website, kind of made some observations, hopefully took in some details as to what was going on. Today I'm going to give you a little assignment. We'll make it worth marks, but it won't be worth much in the way of marks. Uh, with most of the assignments, basically, what I would do is if I'm collecting it, I'd jot it down. I'd give you a quick mark saying more or less that it was done fairly well, or it wasn't, I suppose. And at the end, if they hurt your mark at all, I would drop them. They won't, like I said, not going to be significant. We will have proper tests and so on in the next little bit. So when I'm looking at this, essentially what I'm going to do is just give you a few questions that say pretty much sketch the graph and then state the domain and range. Domain and range was something we did on the first investigation, talking about the linear and the quadratics, something we should be capable of doing with most of our graphs, and not a bad thing to just to be able to sort of fall back on. So getting started here, I'll erase this just for a second. Assuming my page is clean, I see the question says sketch this graph. My starting point tends to be the zeros. So I sort of got written off to the side. You can see if any of those three things is zero, then I'm going to have, if any of those three things multiplies out to zero, or is zero, when we multiply, we'll get a zero for y. Where do these occur? Well, for 2x to be zero, of course, x would have to be zero. For x minus 5, x would be 5. And for x plus 3, x would have to be negative 3. So if this is my question, I'm going to go ahead and just draw it out. And this is more or less what I would expect of you as well. Do a decent job getting some spacing. I could probably have made that y bigger, but as long as you can sort of clearly see with it, we know what goes on at various points, then that's all that matters. So I have a 0 at x is negative 3, right over here, and at x is 5, right over here. Now the only other thing I really need to know is what's going on the ends, sort of those end behaviors that you've probably seen a couple times. Essentially, I have 4 possible ends, 2 of which will occur. As x gets to be really big numbers, I'm going to get one of this or this. And as x goes out towards the negatives, of course, you're going to get one of the other two. So even though it doesn't ask me what the end behaviors are, that's going to be kind of the other really important thing, what goes on at the ends. And as I said before, I don't want you memorizing things. I don't want you thinking, okay, well, this is a 4th power expression, so it's an even number, and there's a positive value out front, a positive coefficient of 2, and that's not how we're going to think this through. We just want to sort of almost test values. So what I'm interested in is, as x heads out towards negative infinity, what happens with y? And you can write as little or as much as you need to get this done. In my head, I can kind of plug in some numbers here and get an idea what's going on. If you can't, then basically when you look at the expression, you do as much as you need to work it out. If I test a value like negative 10,000, well then the 2x becomes a negative number, and so essentially I'm getting y, let's maybe not write an equal sign here, y is headed towards a negative number in the first case, times a negative number for x minus 5, times a negative number for x plus 3, which would then be squared. And so, sorry, I didn't want to put 1s in there. I wanted to put negatives in there. So the 2x is going to be a negative value. let's even write the 2 in there. So it's going to be 2 times the x value, which is negative, times the x minus 5 value, which is a negative minus 5, times a really big negative number plus 3, which is still a negative number. And a negative times a negative times a negative squared tells me that y is going to be positive. So on the outer edge here, I can get rid of this, and my graph will start by kind of heading down this way. Do the exact same thing on the other side with positive values. So I'm saying as x approaches positive infinity, what happens? Well, then basically I just test a positive number, and I get a positive times a positive times a positive squared, which of course is still the same thing. Which means that my graph will kind of come out of the 5 here and head up on to infinity. So these are sort of the ends of the graph. At the zeros, there's sort of one key thing that I haven't yet dealt with, and that was the fact that this term is a double root. So there's technically an x minus 3, and then I sort of wrote it in here again, and another x minus 3 that I need to remember. And what that means is I have basically a parabola at that spot. So my graph is going to, I'm just going to fix it up a little bit here. My graph is going to come down to this 0, and then it's going to kind of go back up. In order to hit the next 0, which is at x equals 0, the graph will have to come back down. And this time it's going to pass right on through and then come back up to finish my graph. Okay, so I have to hit my 3 zeros at 0, 5, and negative 3. Technically, there is a 4th 0 at negative 3 as well, and so I get a little parabola at that spot right over here. The other ones, then I basically have to hit the next 0, so obviously I have to come back down. I pass right on through because at that point I'm basically doing kind of a straight line through 0. Not really straight, but you know, the equivalent of a straight line through 0 and the equivalent of a straight line coming back up. Now, common question would be, how do I know that that's the spot and that that's the spot that I'm going up to or down to? And the answer is I don't. Okay, so if I had drawn this instead, whoa, other than the fact that I missed entirely at the end here. So if I had drawn this instead, through that, back up here, back down here, and then on this way, those two graphs are I would consider to be exactly the same. Based on what we know, we've gone down, hit kind of that parabola at the negative 3, gone back up, come back down through the 0, back up through the 5. Okay, so for our purposes, we don't worry about these maximums and minimums, you can call them. This is a maximum value up here. That's the highest point in that section of the graph. This is the low point in this section of the graph. But we don't worry about those because we don't know anything about them, simply that they exist. Okay. So that's basically what you're going to have as far as questions today. State the domain and range. We'll sort of quick refresher on those. Domain basically is tell us about all the x values. What do we know about what can we summarize about all the x values? And the r value is all the y values. And as I'm talking it through, I'm going to drop that from my intentions. Okay, so there you go. Decision right on the fly during the video. we're going to just deal with sketching the graph, and we're going to not state the domain and range. The reason for that, in case you're sort of wondering why I would make that quick a decision at the last second like this, um, the range specifically, domain for all these questions will be all x values. So always with a polynomial, domain can be anything. Essentially what it's asking me is what numbers can I legally plug into that equation, and I can plug any numbers into that equation. The range, though, is what values occur. What's the largest and what's the smallest possible value in our range for the y values. And of course, I just finished telling you that right down here, this is kind of the low point of the graph, but we don't need to know that. There's no way for us to figure that out in this course. And so we're not going to be dealing with domain and range for these questions, simply because it's not something that's, knowing that low point is not part of the course. So I apologize for that. Have similar activities in the other class right now, and I just got the two sort of quickly confused. Okay, so you can look for some of those. There'll be a Dropbox. Please submit them, and then I'll hopefully get a look at them tonight just to get a feel for how well people are doing. That's as far as we're going with the graphing stuff, and now we're going to, starting tomorrow, we'll do some solving of problems with questions that end up being polynomials. All right, as always, trying to encourage you. I'm on the computer, especially first period of the day. Jump in. If you have questions, hop on Adobe Connect. I've been getting some emails at night, and I've been missing them. I apologize for that. Certainly the school day is when I'm most likely to be caught, but I can't make any super promises. First period of the day, though, the computer is on, the windows are open, and that's going to be your best bet. Take a look at the work. If you have questions about yesterday's work, ask them. If you have questions about today's work for clarification, ask those as well. Thanks a lot.